Hi, I'm Chad Lawson. This is Alternatives to My Internet Radio, and you're watching Verbose Mode. Welcome to Verbose Mode, the show dedicated to learning to learn and the freedom to fail. I'm your host, Chad Lawson. Today we're going to be talking a little bit about the Internet Radio project, but more from the standpoint of alternatives to it, things that I've learned along the way. When I set out to do Verbose Mode, one of the things I wanted to create was more of a why-to series than a how-to. There are plenty of videos on the internet on how to build a project where somebody will go through and talk about how they built their project, but if you're anything like me, when you've seen some of those, you're wondering, you may have even screamed at the screen, why use that? Why not do this? There's always different alternatives. There's always different things you could do with a given project. So I want to take a little bit and talk about this project, specifically in the road not chosen, the path not taken that I could have done with this internet project. And some of them have come along more recently, and some of them are alternatives I didn't even know when I set out to do this project. So I want to talk to you a little bit about the different options we have in here. I've gathered a few different alternatives. The first one I want to talk about is from AdaBox. If you've ever seen anything from adafruit.com, you'll know that they have a subscription box called AdaBox. It comes out quarterly. It's $60 per quarter, and you receive a curated box of products. And what makes AdaBox absolutely wonderful is that the individual components are heavily dealing with breadboarding, so that it's solderless. The absolute devices themselves come already soldered with their headers, so that somebody who isn't comfortable with soldering can pick up these projects and run with it. And box number 4, I'm going to go to my screen over here. Box number 4, called Making Things Dance, had its own options for this particular project. When I received this one and I'm looking through it, I was surprised to see this particular component. Let me get to the close-up here. So this is using one of Adafruit's own products called the Feather. Currently I have their sound card installed on it, their music player. But if I remove this top, what they call their feather wing, you'll see the feather below it. It's a Arduino compatible microcontroller, and each of the feathers has its own unique item to it. This one happens to have a ESP chip on it, which means that it can do internet streaming. You can use it to, I think a lot of the original applications for, and I could be wrong, but what I've seen the ESP chips used a lot for is for being able to create Internet of Things devices, where either you receive a command from the internet and use one of the GPIO pins to pull something on, off, or the other way around, hooking up a sensor to this and then streaming that information through the internet. In this particular project, this is not the first AdaBox to use one of these feathers that has the what they call their Huzzah module on it, the ESP-based chip. This is just the one that happens to be completely dedicated to the idea of making music. The entire box is all themed around that. If I come over here and show you the entire contents for AdaBox 04 is all focused on various music-related, but it starts off with learning how to put it all together. But I love that right here is streaming internet radio. And what's even more amazing to me is this right here. Lady Ada herself started focusing on SomaFM. The entire reason I started building this project was to be able to have a SomaFM internet radio in our house, so that we didn't have to have a dedicated phone, tablet, or anything else streaming the music to some sort of sound system in the house. We could just have a dedicated device whose sole purpose was to play SomaFM music. So right here in this particular code base, they're using SomaFM, which to me was a little bit of a news flash. It hadn't occurred to me at that time to use an Arduino for streaming internet music. I thought if I was going to be doing something streaming from the internet, it had to be a Raspberry Pi, which is what, of course, I've been dealing with on here, and I'm going to continue to do so because I don't need to change gears yet one more time and fall further behind on this project. So this happens to be an example of doing just that. The Feather, the Huzzah-based Feather, which can do the ESP module and stream internet, like our code here. This is one alternative. I could simply add my rotary encoders, a potentiometer to change the volume, and put that in line to be able to adjust the volume. I could have done this all right here and been fine and saved myself a lot of hassle. And this will definitely come in handy for future projects about streaming internet radio, because I've already started working on an Internet Radio 2, also using an older enclosure, but it's going to use this technology instead. Now, one of the other ones that I came across was from it's another, let me bring up the overhead. I'll just go with the close-up for now. This is called Jambox. It's from another one of those subscription services called HackerBoxes. And what HackerBoxes does is it provides a monthly box dedicated to learning a particular project or theme. And what I really like about, I'm going to show you the website for this particular HackerBox. So this one is HackerBox 28. It's $60, so even for 1 month, it's the same price as a quarter with Adafruit. The Adafruit projects, the AdaBoxes, are much more modular. There's so much you can do with any given one. It's much more like a Lego, where you start off with what they give you. If you've ever, I loved the old Legos where you start off, you get their sheet of directions, you make the thing they ask you to make, and then you tear it apart and you make whatever your own heart desires. I think of AdaBox more like that. You have your breadboarded components. You can then, after you've made the thing, take it apart and make other things. The HackerBoxes ones are much more focused on learning a very specific objective and playing with a very specific range of technologies. And while some of them are a little bit more modular, that you can take apart and use those components and other things, things like Jambox here are much more dedicated to one specific task. In the case of Jambox, I've got an ESP module, just like with the AdaBox. I have what's called a digital analog converter, a DAC. This one is using what is called I2S, or actually I think it's pronounced I2S. It's a particular protocol for being able to communicate between chips. So in this case, the ESP chip is using I2S to transmit the data over here. This is then converting it from digital data into an analog form that can be brought out through the headphone jack. They've got a number of nice knobs and buttons, as well as then 4 different 8x8 modules, each of which has something on it called a backpack. It's using a Max driver chip, so that much like if you've ever done anything with what Adafruit calls neopixels, the rest of the world calls a WS2811 or WS2812 LED strip, you send the data into one, it then passes the data onto the next, and onto the next, and onto the next. Similarly, these modules, the driver chip behind them, the Max driver, is able to drive, I send data in and I can completely control all 64 individual LEDs of the 8x8 grid, and then pass that information onto the next 64, and the next 64, and the next. So this one particular board right here could be my entire internet radio project. It has everything I need from being able to control stations, and this code, again being that same ESP Arduino-based code, I could have used the same code out of the Adafruit library, and I could be done. It's another example of being done. I've got a complete board. But again, part of the point of doing this entire project was not to just simply have a finished project, but to learn something along the way. But another thing I like about the HackerBoxes Each of the hacker boxes has an Instructables.com website and mentions this: topics and learning objectives. So each one of the hacker boxes has a specific thing for you to learn. There was a recent one, Biosense, and its job was it gave you the little electrodes to hook up to your head or muscles or a pulse sensor, and to be able to read information from the human body. It was leveraging a number of op-amp chips. These are as famous as their 555 brother. It's another little 8-pin chip, but they're just not as famous as the 555 chip, yet they are just as integral and just as ubiquitous in the electronics world. And so that entire project, that entire hacker box, focused about teaching that, but it gave you a reason to learn it. Another thing I wanted to do when I started talking about this show was to go into the idea of that learning to learn, that every single project requires learning something new. For me, whenever I'm trying to learn a particular concept, I could spend a lot of time on websites, I could pick up books and read books, but I never learn as much as when I actually start tinkering with things. And for that, it's often easier to tinker if I have a particular project to create. And so when I wanted to start dealing with streaming internet radio, it made sense to start on a particular project, my internet radio, my retro tube enclosure. So Jambox and all the different hacker boxes give you that same idea of learning a particular objective, and they give it to you in a project form. So it's another thing I like about this particular collection. Now, the third one that I came along the way is by a company. I'm going to slaughter this name, and I apologize. Pi Moroni. Bring up the close one on this. This is a laser cut kit. All the plastic you see here is laser cut acrylic. It uses a Raspberry Pi. Let's see if I can detach this without damaging the headers along the way. This uses a Pi 0W. It's a $10 single board computer. And in this particular case, I've got the header soldered onto it. Very few of my Pis actually have the header on it. But they have provided their own, I'm going to go to the overhead, their own DAC, their own digital analog converter. But more than that, in this particular hat, it's got a number of buttons for being able to do things as engraved on the side. I can't quite get that in focus at this point, but for next channel, volume up and down, previous channel, pause, play, and the top button being for turning the entire thing off. And then it has the ability to either do a single, with this switch, either a single speaker or dual speaker. They provided the speaker and the connectors. So it's this one, with just being able to do this project and put it together. I'm going to bring you over here to my computer again. So this was the kit I was able to find online. It was $46, so about 2/3 of the price of either a quarterly subscription to AdaBox or 2/3 of the cost of just the one hacker box. The nice thing about this is it's using the exact same technology that I'm using in here. The difference being, you heard me mention in one of the Internet Radio project episodes talking about the challenge was when I first started dealing with the neopixels, the WS2812 LEDs, RGB LEDs, all controllable, was that as soon as I attempted to send sound out through the built-in audio of the Raspberry Pi 3, was that I was getting interference with I could actually hear the data being sent to the 2812s. There was a warble in the output of the sound, and that's because they both share the same data lines, the audio out, that digital analog conversion on the Pi. It uses the same channel as the only pulse width pins that I had to be able to do the neopixels. So that created a challenge and started me down an entirely separate path. Well, then comes along this kit, which I found, I think, last year sometime. And it provides a nice simple setup that all I have to do is It took a little bit of soldering, putting it together. While I was on the road for a particular client visit, I spent some time and soldered it all together. And this, all I have to do is plug this in, and they provide software that will either just instantly pick up. I think it's using a version of VLC, and it has a nice little web interface to it. So from my phone, I can go ahead and connect to the web interface and add additional songs, whether it be an MP3 or similar audio file on the device itself, on the SD card, or a streaming internet feed. The other program that they have built in, or that they provide, is using something called SharePort Sync. And that allows me to, through an iPhone, through Android, to be able to stream the music from my phone, from my tablet, from my computer, directly through this particular speaker. So this has come in handy to be able to have on my workbench, and to either just be able to play internet radio and remind me of what I'm trying to accomplish with the big radio, or to be able to take whatever's on my phone and to have a fairly decent powered speaker. This particular analog converter also has a couple of LED, or I should say, little runs of LEDs to be able to act as an equalizer. It's got two different channels of equalizer for left and right. So this is 3 different options I have, things that I have found along the way. So if you're trying to do an internet radio and you're looking at the project that I've been working on, and you're seeing all these different choices I've made, and you're wondering why didn't you just simply use a Arduino, which could have done the job a lot easier? Well, the answer is partly I didn't know I could do that at the time. I was solely dealing with an Arduino Uno, and I thought the cost of doing an Ethernet card was too expensive, and I didn't know that I could stream internet music with it. I didn't know some of the different options I had when I went to deal with how to compensate for having streaming music and neopixels at the same time. I didn't know that I could use an external digital analog converter. So it's been a learning process along the way. If you've been watching these videos and going, why didn't you do this? Why didn't you do that? Here are some additional options. Here are some additional ways this could have gone. And I would definitely love to hear from you. If you get a chance, stop by our Facebook page, stop by and visit on Twitter. You can find me at Chad Lawson. You can find the show at Verbose Mode TV. Let us know what similar projects you're doing when it comes to streaming music, or if you have any other additional questions. All the particular products that you've seen here and the different software that I've mentioned will be available in the show notes. If you have any questions, let us know. And until next time, try again, fail better.